This is the supplemental video for the analysis of a mixture of sodium carbonate and the sodium bicarbonate lab. Let's begin our discussions by looking at the components of our mixture. We have sodium carbonate and sodium hydrogen carbonate. Now, sodium carbonate is a diprotic base. So, for example, in this will dissociate to produce two sodium ions and the carbonate ion. This is a conjugate base of a weak acid, which is carbonic acid. So how is this going to behave in the course of the titration? So let's look at our titration curve, which is pH versus volume of acid added. So since this is basic, our titration is going to begin at the basic pH. So at this point, the component in solution is the carbonate ion. So as the titration proceeds, pH would begin to decrease because we are adding an acid. It gets to the point of inflection where your carbonate ion is converted to the bicarbonate. So you have and we are adding an acid, so producing HCO3 minus. So at the end point, you're going to have the bicarbonate produced in solution. So at this point, you're going to have what? HCO3 minus. So as we proceed by adding more hydrogen ions from the acid, we're going to convert this product to carbonic acid. Now, carbonic acid is very unstable. Okay, so it would dissociate to produce H2O and CO2. So at the end point, you might see some bubbles in solution. So at this end point, you would have converted your bicarbonate to what? A carbonic acid, H2CO3. So this is going to be your second equivalent point. Let me just make it V2. And this is going to be your first equivalent point, V1. So the volume at the first equivalent point, okay, this V1 is twice the volume at the second equivalent point, or the distance, I would say volume from this point to this point will be the same. So if I multiply V1 by 2, I should get the second equivalent point. Now this is the scenario when you have only sodium carbonate in the mixture, or sorry, in solution. Now for our lab, we have two components. We have sodium carbonate and sodium hydrogen carbonate. So let's look at how it is going to affect the nature of the titration curve. So we're going to have pH versus volume of acid added. We are starting at a basic pH. Get to the first equivalent point. Then, as we keep adding, you're going to have a second equivalent point. Now, we are starting with a bicarbonate. So we have CO3 2 minus at this point. As we keep adding the acid, we convert that to what? The hydrogen carbonate at our first equivalent point. Remember I said at twice the first equivalent point. So let's assume this is twice that. So this is V1, this is 2V1. We will be converting all the bicarbonate to the carbonic acid. So why the extension? Why are we having this extension, this region? Let me use another color. So why are we having this extra extension? Now, so once you are here, you would have converted all the bicarbonate emanating, or all your bicarbonate from your carbonate to a carbonic acid. But your mixture also presented an extra bicarbonate, okay, which is here. So this extension will be as a result of the bicarbonate within the mixture. This is the bicarbonate that resulted from your sodium bicarbonate. So that is why you have the extension, or the extension of your second equivalent point. So if you want to know the amount of moles related to just the second equivalent point, then you are going to first subtract the volume of the second equivalent point from twice the first equivalent point, which is 2V2. Sorry, 2V1. So this will give you the volume of acid that reacted with the bicarbonate in the mixture. So let me just recap everything I've said so far. This is a mixture. So your mixture is going to start with the carbonate converted to bicarbonate, and the bicarbonate being converted to what? Your carbonic acid. So at this point you have H2CO3. The trick here is that at twice the first equivalent point, you would have converted the bicarbonate from the carbonate, or from the sodium carbonate, to your carbonic acid. So the extra bicarbonate which was in your mixture would cause an extension in the equivalent point, or the second equivalent point. So to compute the volume of acid that reacted with just the bicarbonate content, or the sodium bicarbonate content of your mixture, you need to subtract your second equivalent point from twice the volume of the first equivalent point. Now we want to look at the calculations regarding the masses of your sodium carbonate and sodium bicarbonate in the mixture. First, let's look at the first derivative of our pH curve. So if we draw the first derivative curve, okay, you have something like this, where we have HCl and ml. Okay, this is the volume of HCl. So we're going to read your first equivalent point, EQ1, and this is going to be your second equivalent point. Here I'm using the first derivative curves. All right, now the first equivalent point would give us information as to the number of moles that actually reacted with our bicarbonate. So remember I said we have sodium carbonate, okay? In an aqueous system, what you have is actually 2 moles of that. Now, also look closely at this and you realize that the mole ratio of this equals that. So if I'm able to calculate the number of moles of that, that will be equivalent to the number of moles of sodium carbonate. So let's begin our calculation by first calculating the moles of our acid at each equivalent point. So the moles of HCl. So mole of HCl at first equivalent point. So that is going to be the volume of HCl at the first equivalent point, which is here. This is in mils. You have to convert to liters. So in 1 liter, we have what? 1,000 mils. You know the actual molarity of your HCl from your standardization experiment. So I'm going to use approximately 0.100 mole per liter. So this is just, for example, let me just use A moles. Now let's calculate the moles of HCl at the second equivalent point. So mole of HCl at second equivalent point. So volume at second equivalent point, which is this volume. This is a mil multiplied by liter, okay, times 0.10 mole per liter. Now this is going to give us, let's say, C moles of HCl that reacted in the course of the titration at the second equivalent point. Now looking at this, that is the carbonic or the carbonate ion. That is what actually is taking up your HCl. So plus HCl, or I prefer to just use H. So let me just use hydrogen. Okay, so this, as I have already illustrated, will produce what? The bicarbonate ion at the first equivalent point. So the mole ratio of your acid to your carbonate is what 1:1. So our mole ratio is 1:1. Hence, moles of my carbonate will be what? A moles. Remember, at the first equivalent point, we are converting this to that. Now, this is moles of the acid at the second equivalent point. And at the second equivalent point, the reaction occurring is the transformation of our bicarbonate to what? Carbonic acid. As I said earlier, the source of carbonic acid in this titration is two. The first coming from the original sodium carbonate, and the second coming from the actual bicarbonate in the mixture. So let's go ahead and just calculate the mass of the sodium carbonate in the mixture. So since we have the moles of the carbonate here, okay, to be A moles, which again I'm using a hypothetical moles. Remember from this reaction up here, the mole ratio is what? 1:1, meaning that moles of your sodium carbonate will be equal to moles of what? Your carbonate ion. So once we know moles, we can get grams. Okay. So let's go ahead and calculate grams. So since we are using A moles, so we have A moles of sodium carbonate multiplied. We know that in how many grams? So the molar mass of sodium carbonate is 105. So we have 105.988 grams of sodium carbonate in 1 mole. So this will give you, let's use another term, maybe m grams of sodium carbonate. How do we get the actual grams of the bicarbonate in the mixture? To get the moles of the bicarbonate, okay, so the moles of the bicarbonate in your mixture, so let me just use this, will be equal to the moles of HCl reacting at the second equivalent point, which you got C moles, which I've already done here, minus twice the moles of the conversion of the reaction of your HCl with the carbonate. So that I wrote A moles. Okay, so that will give you, so for example, if you multiply this by 2, we expect that the excess here should be coming from your bicarbonate. So C moles minus 2 times A moles, and A moles is the moles of your HCl that reacted with your carbonate at the first equivalent point. We are multiplying by 2, and the difference from the second equivalent point will give us the actual moles of HCl that reacted with the bicarbonate. I'm going ahead to just write moles because once you get that moles, the mole ratio of your HCl to the bicarbonate is actually 1:1. So let's assume this gives you K moles. Once you have K moles of the bicarbonate, remember this is bicarbonate in the mixture. So mass will be calculated in the same fashion because your bicarbonate, okay, so sodium, hydrogen, carbonate, which is what you actually have in the mixture. So this is going to produce 1 sodium plus your HCO3 minus. All right, so once you find these moles, which is K, that will be equal to the moles of your bicarbonate. So let's calculate for the mass of your bicarbonate in the mixture. So you have K moles of your sodium hydrogen carbonate multiplied. The molar mass of that is 84.006 grams of sodium hydrogen carbonate in 1 mole. So remember the grams you've calculated. Okay, so let's say this gives you n grams. Okay, so you have m grams of the sodium carbonate and n grams of the sodium hydrogen carbonate. Remember, you guys made, I think, a total of 250 and just titrated 25. So the grams you use actually is just a factor of 10 less. So to get the actual grams, so the actual grams of your sodium carbonate would be m grams times 10. Then the actual mass of your sodium bicarbonate will also be what? N grams times 10. So from here, I believe you should be able to do the rest by yourself. I know it is quite late, so I hope you guys will be able to complete this write-up as soon as possible. Again, if you have any questions with regards to lab, I would encourage you to email me way ahead of time. Okay, all right, all the best, and hope to see you guys tomorrow.